Hi, my name is Giovanni Cecere. I am a PhD student at Politecnico Torino and am carrying out my research activity in collaboration with the STEMS Institute of National Research Council of Italy. My activity is so focused on the investigation of efficient use of hydrogen in small-sized spark ignition engine. Then let's start from an overall overview on what's happening in the world, more in detail on the climate change and its effects on the environment. In this context, looking at the global CO2 emissions chart, it is possible to recognize how the share attributed to the road transport sector represents approximately the 18% of total CO2 emissions. So why start the other solutions if we already have the battery electric vehicles? The answer is linked to the structural problems and the intrinsic weakness which leads this technology to be poorly suited to satisfy the entire road transport sector requirements. Thus, in this scenario, the use of hydrogen in internal combustion engine can represent an intermediate and attractive solution towards the zero emissions target. Then, in my first year of research activity, starting from the experimental data and engine specifications, me and my research group developed a 0D 1D model so as to allow the simulation of hydrogen operations, with particular attention during the calibration phase and definition of combustion characteristics. The addition of hydrogen showed several advantages at medium-high loads, with relevant gain in terms of indicated power and efficiency, and in order to adapt the flame front speed to the higher crankshaft velocities, the optimal hydrogen ratio increased with the engine speed. Moreover, it is also important to note how the methane and blend fuel mode showed similar crank angles degree for which the 50% of the mass fraction band was achieved, thus highlighting the few modifications needed by the addition of hydrogen. On the other hand, this investigation also revealed some critical issues. First of all, the theory suggests that the pressure peak should be located of around 16 degrees after TDC, then losing a part of the gained efficiency. Moreover, at the low speed, the pure hydrogen fuel mode showed a critical pressure gradient, thus limiting its addition to lower ratios or higher engine speeds. For my second year, further analysis on more extended load map are expected, coupled with the experimental analysis of the hydrogen fuel jet during my abroad period. So I would like to thank you for your attention, and for any doubt or question please feel free to send me an email.